This is Tom Black, Super Chemist. I'll show you a database that has hundreds of salts and the solubilities for it. But let me go into something else. Down there in the bottom right corner there, the place I'm talking about is Wikipedia. And I did a video about azeotropes, a database for azeotropes, where you can punch in up to 3 chemicals and it'll tell you if there's a binary azeotrope, a ternary azeotrope, or no azeotrope at all, and then it tells you the compositions and, boiling points and all that. Wikipedia also has, it's called azeotrope tables, and it'll give you the boiling point for the azeotrope if there is one, percentage by weight, specific gravity. They do have some ternary azeotropes on there. It's not a big database like the database in the video where I talk about azeotropes. It's not that big, but it's something just in case you can't find it on the one, you can look on there. Now the solubility table I'm talking about is on wikipedia.com. I don't know why people are always asking, like, how do you make something or how do you do this? It's always on Wikipedia. You know what I mean? You want to know the boiling point of something, methanol, punch in methanol into Wikipedia, and on the right-hand side at the top, there's a chart that tells you stuff like boiling point, specific gravity, what it's soluble in, what it's not soluble in, that kind of stuff. But there's also on Wikipedia, you can see right here, solubility table. You punch that in, it'll look like this. You'll have an alphabet up on top, and you'll have a list going. It'll say substance, formula. I don't have all the degrees down, but it goes 0 degrees, 10 degrees, 20 degrees, 30 degrees, increments of 10 degrees, all the way up to 100 degrees Celsius. And then it'll give you grams per 100 milliliters of water that it's soluble in. I didn't do it for the first one, but the second one, look, this would be 0 degrees, this would be 10 degrees, and then it would go on and on, okay? There's hundreds of salts. As you can see, actinium 3 hydroxide, that's not a common salt. So, I mean, a lot of them are common salts, just binary salts or whatever. But there are some unusual salts. And like I said, there's hundreds of them. The reason why they have the alphabet up here is because it's so long to scroll. You can't scroll through it. But if you have a salt that starts with the letter P, you're going to want to just click on the letter up here, and then it'll start you on that list of the P's. Otherwise, you'll be scrolling for half an hour to get down to the P's. Now, another solubility thing they have on Wikipedia, you can plug in solubility chart, okay? And what it does is it gives you a little grid, gives you cations going up and down, anions going horizontal. And then they'll list it, like, looky here. You got lithium, you have fluoride. See, right where they go, there's an SS. It'll tell you, it's just a little paragraph, tells you what the letters are for. SS is most likely slightly soluble. S would be soluble. But you can see sodium, and then you just connect them to where they go, and it'll tell you if that salt is soluble. Sodium chloride would be here, sodium iodide, lithium chloride, lithium iodide, and it goes on. I'm not showing the whole chart, obviously, but it's nice and helpful just to look it over or whatever. But it's a nice little database. While I have you on here, I wanted to talk about Wikipedia because they do have so much information on there. People downplay it. I used to downplay it, or think it was stupid because anybody can just add stuff to it. But the truth is that they don't have as many mistakes as you think. I mean, everybody, even the Encyclopedia Britannica, every book has a certain percentage of mistakes. And Wikipedia does not have really, compared to the Encyclopedia Britannica, it supposedly has less mistakes. You know what I mean? One has like 4%, one has 5% mistakes or something. I don't know what it is. And you can, I actually went in and changed something on it, put something in there that was incorrect, only because it was incorrect in the first place. So you can put misinformation in there. I keep meaning to look up the real thing and put it in there. But anyways, a lot of stuff in there. How do you make something? You want to know how to make blah blah blah. Go to Wikipedia, type in blah blah blah. Okay? They have a table of contents. Go down to the table of contents where it says production. Click on production, or just scroll down to where production is. It'll tell you 50 ways to make it. You know what I mean? You want to know the boiling point of something? Put it into Wikipedia. Like I said, on the right-hand side, it'll tell you pKa. It'll tell you all kinds of information, solubilities, molar mass. Why figure out molar mass when you can just look it up on Wikipedia? Like if you have something that has a lot of atoms in it, you know what I mean, to make up the compound. You don't want to look at all them up to see what the molecular weights are, and then add them all together. You can just go to Wikipedia, punch in the thing, and look on the thing. It'll tell you molar mass. It'll also tell you in that chart if it's, most times it'll tell you, not all times. It'll tell you if it has any kind of water in it, you know what I mean, like a water of crystallization. It'll tell you how many, and it'll tell you stuff about that, about the because you could have 4 waters on it, you could have 3 waters of crystallization, you could have 2, on the same compound. There could be several different types of water crystallization depending on how many water molecules are on there. Like I said, what it's soluble in, what it's not soluble in, boiling point, freezing point, all kinds of stuff. Wikipedia is the greatest thing for a chemist. You know what I mean? There's so much information on there. Sometimes I just read for hours and hours, looking up chemicals and reading everything it got to say about it. I'll look up sulfuric acid. I don't care. I know what sulfuric acid is. But you always, so especially sulfuric acid, it's got a long whatever. Just for review, just to, it's a great source of information. They got a lot of databases on there. Also, you got like ethanol, any kind of chemical you can go to. I forget what it's called. Let me see. Database. There's an MSDS, basically what I'm saying, on Wikipedia for all kinds of chemicals. If you want the MSDS but it's not called MSDS. It's called something else. I'll have to put that in the description, maybe. So I don't have an editor, so I'm trying to keep this flowing. But I think that's all I got to say. Like I said, this is a great database. You want to know something soluble, how soluble it is. And you don't just want it at room temperature. I hate that when I want to know from 0, 10, 20, 30, 40, all the way up to 100. I want to know increments. I don't want, this tells you everything like that. So anyways, y'all have a great day. Always remember, science is great.